Hello, everybody. Today's lesson is going to be about probability. Our lesson objective for today reads students will be able to find the probability of independent and dependent events. Your title for your page today is, of course, probability. And let's start by defining what that is. Probability is the likelihood of an event occurring. The likelihood of an event occurring. Probability ranges from 0 to 1. So draw a number line going from 0 on one end to 1 on the other. So if an event has a probability of 0, that means that that event is impossible. Write the word impossible on top of 0. You don't have to draw the pictures. That's going to take you quite some time. But for impossible, I want you to put rolling a 14. If you have two dice and each dice goes up to 6, 6 and 6 is 12. So it's not possible that you can roll a 14 with two dice. That's an example of an impossible event. On the other end of this number line, we have 1. 1 means that something is certain to happen. In Dallas, the sun will rise. Every day, the sun will come up. You might not see it every day because of the clouds, but the sun will rise. Exactly in the middle, we have 50%, 0.50, 1 out of 2. And for an example for that, we're going to use a coin flip. Flip a coin. A coin has two sides. One is heads, one is tails. That's exactly 1/2, 0.5, 50% probability. Now, the 50% divides the probability line into things that are unlikely. Write the word unlikely right here. And then it also divides it into the other half, which is likely. So sometimes an event might be more unlikely, it might be more likely. Something that is unlikely is rolling a 1. There's 6 sides to a dice, 1 out of 6. That's not impossible, but it's unlikely that you're going to get exactly a 1 if you roll a dice. Now, underneath likely, I want you to draw 5 marbles, color in 4 of them. Since we don't have colors, we're just going to say black. The probability of pulling black is 4 out of 5. So that's more likely. That's a likely event. It's more, you have more than a 50% chance of it happening because there's more black marbles than white ones, okay? So that's a probability line. That's a probability basically is. That's just a review from middle school. Today, we're gonna be talking particularly about independent and dependent events. So 2 events are independent if the occurrence of one does not affect the likelihood of the other. Independent. Think about that Beyonce song. I don't know if you know it, Independent Woman, right? Beyonce is independent. She has her own money, her own job, her own everything. What Jay-Z does not affect her at all. She is independent of him, right? Whereas dependent, think if you have like a little puppy, the puppy is dependent on its owner to feed it. It's dependent on its owner to walk it. A newborn baby is also dependent, okay? So 2 events are dependent if the occurrence of one does affect the likelihood of the other. So when you're comparing events, they're either going to be independent of each other or they're going to be dependent of each other. Let's do some examples. We're going to start with examples of just simple probability, and then we'll move into independent, dependent. So our first example, we have a bag of marbles here. What is the probability of pulling a black marble out of the bag below? So the probability of black is going to equal black over the total. Probability is always out of total, okay? How many black marbles are there? 1, 2, 3. There's 3 black marbles. How many marbles are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. So the probability of pulling a black marble out of that bag without looking is 3 out of 10. 3 out of 10 cannot be simplified. That's our final answer. Next example. What is the probability of spinning the spinner below and landing on yellow? So probability of yellow is what we're looking for. That's going to equal yellow over the total. How many yellow sections are on this spinner? 1, 2. How many sections are on the spinner in total? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. So the probability of yellow is 2 out of 8. But 2 out of 8 is not in simplest form, so that's not how the answer is going to be written on your test. We're going to have to simplify that. Let's use Desmos. Make a fraction, 2 out of 8. No decimals, fraction, 1 out of 4. So 2 out of 8 simplifies to 1 over 4. Therefore, the probability of spinning yellow on this spinner is 1 out of 4. What is the probability of flipping a coin and it landing on heads? No picture for this one, but we know what a coin looks like, so we don't need a picture. We're looking for probability of heads. That's going to be heads over total. How many heads are on a coin? 1. How many sides are on a coin in total? 2. So the probability of flipping a coin and it landing on heads is 1 out of 2. We cannot simplify that. That's in simplest form. Okay, so that's just a review of simple, basic probability. Now let's move into independent probability. Remember, independent is when these events do not affect each other. We have here a spinner, a dice. I unrolled it for you so that you can see every face, and we have a coin, okay? What you spin on the spinner is not going to affect what you get when you roll the dice. You flip the coin, what you get on the coin is not going to affect what you get on the spinner. Say you roll the dice twice in a row. What you get on the first roll is not going to affect what you get on the second roll. That's why these are independent events, okay? So the first one, what is the probability of spinning red and then spinning blue? So we're going to have probability of red times probability of blue. When you're finding 2 events, the probability of them, you multiply them together, okay? So probability of red, there are 1, 2, 3, 4 red sections on this spinner, and there's 8 sections altogether. So probability of red is 4 out of 8 times blue. There are 1, 2, 3 blue sections out of 8 sections altogether. So 3 out of 8. We're going to multiply. Now you can multiply across 4 times 3 is 12. 8 times 8 is 64. And then you'd have to just simplify that and you get 3 out of 16. But that's 2 steps instead of 1. You could just put this entire thing into Desmos. That's what I would do to save time, honestly. Let's do it. We need the fraction, 4 on top, 8 in the denominator, times another fraction, 3 in the numerator, 8 in the denominator. It's going to give you 0.1875. You know I don't like fractions. I don't like decimals. I want fractions. Hit that little button. It gives you the same thing, 3 out of 16. So the probability of spinning red and then spinning again and getting blue is 3 out of 16. What is the probability of rolling a 6 and then landing on heads? So probability of 6 times the probability of heads. There is 1 6 on this dice. 1 6, and there are 6 sides in the dice total. So the probability of getting a 6 is 1 out of 6 times the coin has 2 sides, only 1 side is heads. So the probability of flipping and getting a heads is 1 out of 2. So we have 1 over 6 times 1 over 2. Use Desmos. 1 out of 6 times 1 out of 2. And that's going to give us 1 out of 12. So the probability of rolling a 6 and then landing on heads is 1 out of 12. What is the probability of landing on red, rolling a 5, and then landing on tails? This is 3 events now. Okay, so probability of red times probability of a 5 times the probability of tails. All right, so again, red, there's 4 sections out of 8 times there's 1 5 out of, oops. That's a very common mistake. When they ask you for probability of 5, you put the 5. No, there's only 1 5. 1 out of 6 sides on the dice times tails, 1 out of 2. So we have 4 over 8 times 1 over 6 times 1 over 2. Four out of 8 times 1 out of 6 times 1 out of 2. You get 1 out of 24. So the probability of spinning red, rolling 5, and doing tails, getting tails, if you do all these 3 things back to back to back, is 1 out of 24. Okay, so those were independent events. Now we're gonna do dependent events. Again, dependent means that the first one happening is going to alter the probability of the second one happening. It's going to affect the second event, okay? Here we have some bags of marbles, a bag of marbles, and then we have a box of, like, you know, you ever played Scrabble, you got the letters and you reach in the bag, you don't know what letters you're gonna have. So pretend that's a bag of Scrabble and those are the letters that's in the bag, okay? So for the first example, they're saying, what is the probability of pulling a green marble and then a red marble without replacement? So without replacement means that you're gonna pull one out and you're not going to put it back. Without replacement is the most common type of dependent probability that you're gonna see. That's what you're gonna see in the test. So green marble, there are 1, 2, 3, 4 green marbles out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 altogether. So 4 out of 10 is the probability of getting green. Now, if we successfully get a green marble, there's 1 less marble in the bag, 1 less green marble in the bag. That one's gone, okay? So when we go to find the probability of red, oh, I forgot to write this out. Probability green times probability red. How many red marbles are in this bag? 1, 2, 3. But there's no longer 10 marbles, okay? Because we took out 1 and we did not put it back. So there is now 1, 2, 3, 4, 5, 6, 7, 8, 9. There is now 9 green marbles. So put 4 out of 10 times 3 out of 9 into Desmos, and you are going to get 2 out of 15. I'm not going to waste time doing it. We know how to use Desmos. Next example, what is the probability of pulling a vowel and then pulling a consonant? So vowels, if you don't know, are A, E, I, O, U. That's elementary school a long time ago. You might not know. All right. So how many A, E, I, O's, and U's are up here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vowels, okay? So we want the probability of the vowel times the probability of the consonant. There are 8 vowels we just said out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 Scrabble tiles altogether. So if we successfully pull out a vowel, just pick one, cross one of them out. That's gone. Times, now we want a consonant. How many consonants are there? How many non-vowels? Consonants are letters that are not vowels. We got 1, 2, 3, 4, 5, 6, 7. There are 7 consonants out of how many towels are in there now? There was 15, but we took 1 out. So there is 14 left. So 8 over 7 times 15 over 14. My final answer for this is going to be 4 out of 15. The probability of me pulling a vowel and then pulling a consonant back to back is 4 out of 15. Last one. What is the probability of pulling 2 consonants back to back without replacement? So we're using the same thing. I'm going to erase this so it's less confusing. Okay. So probability of consonant times the probability of another consonant. There are 1, 2, oops, I'm doing vowels. 1, 2, 3, 4, 5, 6, 7 consonants out of 15 tiles times, cross 1 out, doesn't matter which one you cross out. Now there are 1, 2, 3, 4, 5, 6 consonants left, and there are 14 tiles left. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You count everything except the one that's colored out, crossed out. So 7 out of 15 times 6 out of 14 gives you 1 out of 5. The probability of you pulling 2 consonants back to back is 1/5. All right, so that concludes our lesson today on probability. Good luck on your classwork.